everyone, I'm Wendy. I introduced broken line linear model last time. It is not popular, so that I think you are not familiar with this model. That's why I like to see again briefly, and I will take example for this model. All right, last time, uh, sometimes relationship between x and y, whether empirical or theoretical, okay, can vary according to the range of x. At some turning point of x, the linear relationship change, like before some value x0, the relationship y hat equal to a plus bx, and after x0, it change to y hat equal to c plus dx, something like that. So I think there's many kind of data you may encounter. So in that case, turning point is 1,000. Then variable, explanatory variable x1 is at what? 1,000. You have to add this term like this. So x1 is a production volume, and x2, this one is dummy variable. It takes one, x1 greater than equal to 1,000, turning point I call, and x1 less than 1,000, x2 takes 0, like this, okay? So the graph is like this, x and y relationship, okay? Before 1,000, like this, and after 1,000, relationship change to like this. I talk about EX because EX is EY and X has a line, okay, follow line here. I do not take epsilon here. That's why I take expectation of Y and X. Understand that? Okay, let's see. Example. Following data pertains to the number of employees, X, and the profit per employee, Y, at 8 regional headquarters of a financial institution. The scatter plot of this data is shown like this, X from what, 30, okay, 30 to 80, and Y takes 1.5 to 4.5, something like that. Okay, the scatter plot, you cannot catch the shape of line from this kind of diagram, but it looks linear relation from here to here, and another one like this, a little steeper. So I choose 50, and from 50, the relationship change like this, okay? Is it parallel? No, I don't think so. So there is, uh, relationship x and expect y like this here. Say y hat from a plus bx. From here, y hat is c plus dx. Okay? Change the what? Intercept and slope. Okay. Depend on the number of employees is around 50. So the broken line piecewise linear regression model for this data is like this. Okay, I took g here, variable g, instead of x2 before, but it is the same. G, it takes 1, x greater than equal to 50, x g takes 0, x less than 50. So you do not know the broken line linear model, then you will apply simple linear regression model, and the estimated simple regression equation obtained from solving this data is like this, simply. y hat equal to 6.7946 minus 0.0632x. R square, it is good enough, 95.2%. This estimators, okay, p-value is very small. In contrast, the estimated regression line based on the broken line model from this model, then you may get y hat equal to 5.8954 minus 0.0395x minus 0.0389 x minus 50 g. Okay, so the result from here, 5.8954 p-value is 0.000. This one, as the coefficient of x is minus 0.395, p-value 0.045, and the last one is minus 0.389, and the p-value 0.153. P-value is bigger than 10% p-value. I think you may take the criterion of p-value is, I think, 10%, 0.1 for social science data. For laboratory data from some research laboratory data, you may take p-value 0.01. Okay, that is my argument. So social science, even though it is pretty bigger than 0.1, so it is not what, non-significant. So it may not be included in the model, although the p-value for beta 2 hat is 0.153, indicating it is not statistically significant. Okay, but it is still advisable to use the estimated broken line, this line, to predict profit per employee for a certain number of workers, x0. Okay, for prediction, it is not make trouble. So you may use this estimated line. Okay, and R square is 969, about the 10%. What? Not 10%, 1%, 1.7% increase R square. So I think you may disregard this result for this simple case, but I recommend use this broken line estimated thing can be used for prediction. Okay? All right, that's it. The broken line linear model. I'm going to introduce another one, a little revised one, broken line with jump next time. Okay, that's it today. Thank you.